All right, so any homework questions? Yes.
Section 4.4, page 257.
Number
54.
54. 54 and 4.4. So it says find the LCD. Page 2, what did you say?
57.
Section 4.4. So who remembers the way I showed you? There's a couple different ways you can do this. You can always take the bigger one and just start counting in multiples of it. Right? So you could say 20, 40, 60, 80. Now, did I hit one that 12 goes into also? Yes. Which one does 12 go into? 60. So that's the idea. The idea behind an LCD is there a number that can multiply both things by something and they become that number? That would be CD. And what's the lowest one of those? Right? Because I can certainly make both of these become 120. That would be a common denominator, but the lowest common denominator is 60. Because 20 can definitely become 60, right? 20 times 3. And 12 can become 60 because that's 12 times 5. I love it. Right? Now, of course, the less familiar you are with what 12 goes into, the less useful this approach is. So there's another approach. Does anybody remember, that's the approach I like to use a lot.
Like multiply two numbers and get 12, and multiply two numbers and get 20.
Exactly, but you always want to use the number they have in common. So what number do they have, and what's the largest thing they have in common? 4. So 12 is 4 times 3. 20 is 4 times 5. Now it's very simple to see who's missing what. What's the first guy missing?
5.
Yeah, he's missing that 5, right? So you give him a 5. Well, what's this guy missing?
3.
A 3. So you give him a 3.
You're multiplying?
Oh yeah. Because it's the
5 times 7, 5 times 12.
Yep. So these are both the same thing. Is that cool? I did 12 to get 4 times 3. So when I multiply the top by 5, I multiply the bottom by 5. I just did it in both representations. So what number's on the bottom now? 60. And what number would it be on the top there? And this would be
9.
over 60. And see, like we did here, 3 20s make 60, so of course you multiply that by 3. 5 12s make 60, so you multiply that by 5. I mean, either way you do it, you end up multiplying by the same number. It's just that this method deals with smaller numbers. This method, your list can get up pretty gross. And then you're like, which number does my other number go into? That's a little harder.
It's kind of like a shortcut.
Yeah, this way, the reason I like this way so much better is because it actually helps you further in math. So if you get used to doing fractions this way, when you start getting uglier fractions with variable expressions on the bottom, and you're doing things called factoring and stuff, the same approach we're using here is used there. So I like to try to show you things that will help you in the future. So the actual answer here would be the LCD is
60?
60.
So 5 times 12 is 60. 5 times 4 times 3 is 60.
Yes, exactly. So these are the same.
Yeah, those are.
12 is 4 times 3. If I multiply by 5, I'm going to get 60 either way I look at it.
So just disregard the top.
Yeah, I've rewritten the bottom like that, and I've rewritten the bottom like that. Is that better? So all I did was, this was 7 over 12, and this was 3 over 20. So first I rewrote it as 7 over 4 times 3, and 3 over 4 times 5.
And so then you just take out, you move over what's missing.
He's missing
from
a
that.
5, and he's missing a 3. Now, it almost makes too much sense. If you give each one what they're missing relative to the other one, they're going to end up with the same damn thing, right? It's like kids. He's got more than me. He's got more than me. Or you just take the whole damn thing and eat it yourself. That's probably why it's better if not a parent.
Yeah.
You're bigger. Give me out. It's yummy. End the problem, right? That's the
Bigger problem.
tiger dad
But you've
approach.
still got 2 whining kids, so.
No, they need to throw them in a room. Yeah.
Now, when we do the 35 and the 9 and then the 60, did you want us to simplify that
No,
equation?
no, no. This problem just wanted the LCD.
Okay.
In fact, they didn't even put in between if it are they adding, are they subtracting.
Okay.
Yeah. Cool. You with me? So that problem just wants LCD. It's not asking you to add or subtract.
Okay.
Cool. What kind of problem do I need an LCD? What operations do I need LCD for?
Division, addition and subtraction.
Addition, subtraction, because that's when you need like terms. Multiplication, division, that doesn't make any sense. Multiplication, division is all about canceling stuff that's there. This is all about making everything bigger. That's the opposite. I want to kill stuff when I'm multiplying and dividing. Adding, subtracting, I have to have like terms. So I have to have like denominators. Okay, any other questions? Did you?
Oh, wait. Yeah.
You good?
It's section 4.3, and I was having trouble with 24, 33, and 39.
$24, 33, and 39. Freakadelic. Okay. See, 24. 24 is looks difficult when you look at it because there's a little more going on than we're used to with this kind of problem. This is section 4.3. So, what's going to save you in this situation? What is always true, even if we're outside of that section? Something from earlier, something that had its own saying. PEMDAS. So, what does PEMDAS say I got to do here first? Well, there's nothing to do in there, is there? So, exponents. So, I got to do this to this. Yeah, what's negative 3 cubed? Yeah, so this will be negative 27. Is that cool? You guys with me? And the bottom would be 4 cubed, which is 4, 4, 4. So let me write it like this. The top would be negative 3 times negative 3 times negative 3. Right? 3 of these multiplied. And the bottom would be 3 4s multiplied. So you get negative 27. How do I know it's negative? There's 3 negatives. 2 of them can't. Oh, 2 of them cancel, leaving you with 1. 4 4 4 is 64. So that's the cube of 3/4 is 27 over 64, and the negative is still there because there's 3 of them, right? And then you still have the times 1/3. Now, how do you do that? Yeah, what happens here that's nice? Yeah, 3 goes into 27.
I missed the 24 and 64. Or
Oh.
27 and 64.
So that was, are you cool with from here to there?
Yes.
And then when you multiply this, you get negative 27.
Oh, because it's 9 and then times 3.
Exactly. And then
Gotcha.
16 times 4, 64. Now you could multiply and get negative 27 over 192.
No.
Yeah, exactly. I don't want to do that crap. I don't want to give myself these big ass numbers that I have to figure out what goes into them. I want to work with the smaller ass numbers. Right? So 3 goes into 27 9 times, and now you just multiply. straight across. So you end up with negative 9 over 64. Yes, ma'am.
So the negative 3/4 doesn't apply to the whole 3/4, it only applies to the top number 3?
The negative, you mean?
Yeah.
If it applied to both the top and the bottom, is that still negative? What will the negatives do? Cancel. So that would be positive. So if I see negative 3/4, that's the same thing as negative 3 over 4. That's the same thing as 3 over negative 4. Those are all the same. Because they are all 3/4 with a negative in it somewhere. Right? So it can't possibly apply to top and bottom because then it would cancel itself out. Of course you can have a negative 3/4. I got one right there. So, but I can't have a negative 3 over negative 4. I can't, from one negative, I can't have 2. So the problem here is 3/4 is 0.75. Is that cool? If you were to divide it, you get that decimal. I know we haven't talked about decimals yet, but we've seen them. So negative 3/4 is that number. Math doesn't care how I represent this number. It says you can represent it like that. You could represent it like that. Or you can represent with a negative in front of 3 over 4. Math doesn't care.
Which do you prefer?
Yes, whatever you like. So what do I like?
No, I'm saying it's like
That's what's better.
whichever you prefer.
But that's
This comes in first place, this comes in second place, and this is last.
That's kind of confusing. That's confusing me because it's saying that the negative only applies to the top number, not the bottom.
No, it could apply to the bottom instead if you wanted to.
But then,
Now watch. Give me two numbers that make negative 16 when you multiply them.
Negative 4 plus
4.
Well, 4 is not a great example. All right, 2 and 8. So negative 2 and 8, right?
Right.
Now isn't 2 times negative 8 the same damn number?
Yes.
You with me? So math wouldn't care how you broke 16 up. Negative 16, it doesn't care where you put the negative as long as there is a negative somewhere. So 0.75 is 3/4. If you have negative 0.75, math doesn't care which one gets a negative. It just says there's got to be a freaking negative somewhere in there. Not 2, because then it would cancel and you're supposed to have one. So math says, I don't know, you can put it up there, or you can put it down there, or you can put it in front.
Doesn't that make your number different though?
No.
That's what I was wondering. What makes your number different?
How?
No, because at the end, like, it'll still be negative 9. It could be negative in front of the 9 over 64. All
All right, let's do this. Let's do this.
Or it could be 9.
Let's do this. Let's try something we can actually do without decimals. What's 18 divided by negative 3?
Negative 6.
Negative 6, you with me? So far so good? What's negative 18 divided by 3? Okay, now, so both of those are the same. Did moving the negative change the number? They both represent negative 6. And if I do this, 18 divided by 3 is 6, put a negative on it. So it's still negative 6.
So it doesn't matter where the negatives are.
Doesn't matter.
Whichever is more appealing to you.
Yeah, whatever.
That's why I said, like, whatever
Oh.
works easier.
But I'm trying to tell you, this one is last. You almost never just leave the negative on the bottom. I prefer this one, but sometimes this is okay. So these kind of tie a little bit. Those are, conventionally, that's good. But if you put it down there, I can't say you're wrong. Really? How's that? Is that cool? That's a little weird, but it shouldn't surprise us. 18 divided by negative 3 is the same number as negative 18 divided by 3. They both come out to be negative 6. So it really doesn't matter where you put the negative. It doesn't change the number. They both represent the same number. Okay. All right. Any other questions from over here?
Like you were saying, you can't always put it in front because in some cases you'll have like a symbol between like two fractions, right?
So if you had 7/8 minus negative 2/9 or something.
Something like that.
Yeah. So I mean, if you did, you could put it out front as long as you put the parentheses in there. Yeah. Yeah.
So same.
So there, it still doesn't matter where you put the negative. Just normally we put it there, or we put it up on the top. We very rarely put it on the
But
bottom.
once the parentheses are there, then you can't cancel them out, right?
Oh no, these will definitely still, what's minus a negative? Plus.
Oh, okay. So
The only reason we do that is because if we do this, this might become one giant, remember like the unibrow? Yeah. So the only reason we put that up there is so that these two symbols don't become one big ass minus symbol, right? It just reminds us that we have minus and negative, not one big minus.
I got you.
Math doesn't need that parentheses there. We do as humans. You're like, I can't see that. Okay. Anything else from homework? Or general questions? Yes?
When multiplying the fractions, it's not wrong, then you just multiply it out.
It's not wrong.
You just end up making more work, but it doesn't help.
But I really desperately, it's more than a suggestion. Let me give an example. Here's a little review problem. Let me throw some negatives in here. What you got, Jeff? Sure. So I really do not feel like doing 48 times 77 big ass answer, 54 times 88 big ass number, and then trying to reduce that, right? Are you with me? Does that make sense? If I don't have to, I'm not going to make my numbers huge if I don't have to. Because that's really what's the more difficult simplification problem for a fraction? To reduce it is when the numbers are big and it's not easy to see what's common. Does 3 go into both? Does 80 go into both? There's huge numbers, I don't know. So I'd rather make my numbers smaller at first. And thankfully I'm allowed to. So what happens here? Yeah, 6 goes into both. So it becomes 48 divided by 6. 8. Negative 8, good. 54 divided by 6. 9. And what goes into both of these, of course? 11.
7.
7 over 8.
Yes, 7 over 8. And then,
8 goes over 8.
The 8 numbers.
you guys are right. This is hilarious. You got an 8. No. I don't understand it. And then here you get what now at the end?
And negative 7.
You get negative 7. 1 times 7, so negative 7 over 9. That was a hell of a lot better than whatever 48 times 77 is.
Why is it okay for the negative 8 to cancel out the positive?
Well, because if 8 divided by 8 is 1, negative 8 divided by 8 is negative 1. So really, I left the negative there. So if you wanted to, you could say, what I'm really doing is actually I just did the 8 and the 8 is 1, but the negative is still there.
Oh, okay.
That's even a better way.
Okay.
Yeah.
Okay, and I see, and that's how you got it. Okay.
Yeah, so I know there's a negative. 1 times 7 is negative 7, and so forth.
Okay.
Is that cool? So that's why when you multiply fractions, if you can, you reduce up and bottom or diagonally across. The mistake people make, like the other question, one of the other questions was number 39. So a couple levels of mistake here. People start to cancel this stuff, but can you do that?
You have to flip it first.
No, I have division and division. That can't cancel each other out. Good. So you flip. And still, though, people still are somehow able to cancel these. They can't cancel. They're multiplying each other. They're the same level. It's only if one's up and one's down. Then they're being separated by division and it's multiplication, so they will cancel. Here, these don't cancel. In fact, does anything cancel? Nothing cancels. So then you just got to multiply 3x times 6x. Good. 18x squared. I love it. Divided by 35. That's it. It's not going anywhere. So don't think you're making a mistake if nothing cancels. It just happens to be a problem where nothing cancels. Doesn't have to cancel. Maybe. So anything else from? Yeah.
Just, so if that 3x over 7 was plus 6x instead of times, well, I guess you have to have like this common denominator there.
Yeah.
My question is mainly pertaining to the x's. So,
All right, so let's try it out. What if I had this? Now, this is the only time the LCD is this bottom times that bottom is if the bottoms don't share anything. 7 and 5, do they share any factors? No, they're each prime. How can they share anything? So that means the LCD is just going to be 7 times 5, 35. Because this guy's missing him and he's missing, aw. Sorry. So then this guy you multiply by 5. This guy you multiply by 7. So what do I get here? 15x over 35 plus 42x over 35.
yeah, so then do you do this?
What's the matter? Wait. Where did I lose you? What's up?
Why do we add like 5 and 7?
So the problem was this. You with me? I cannot add or subtract anything unless the things I have are like terms.
Yeah, like,
Here I got 3x 7s and 6x 5ths. I mean, they're not like terms. They don't have the same stuff. With me? So if I can make them both over the same number, now I have 15x of these plus 42x of the same thing, I can put those together.
so then you add the 15 and the 42, and then what happens to the x? The x carries over?
Oh, we
or-
know exactly. No, there's no question about. When I see this 15x, okay, now let me just freak your mind out a little bit more. There is no 15 there. What does 15x really mean?
15 times 15.
15x is adding together, right? So coefficients are just keeping track of how many x's I've got. So if I got 15 x's in a row there, and I tack on another 42 x's in a row there, how many x's total do I have in a row? 57. So I have 57 x's in a row. So we know that 2x plus 3x is 5x. Right? We know that. We should know that. We've done that. But that's why. If I have, it's just because I don't want to write 15 x's. If I have 2x plus 3x, it's x plus x, that's 2x. And on the end of that, I'm putting x plus x plus x, that's 3x. Right? When I add 2x to 3x, I do end up with a string of 5x's. So it's exactly how I write it. Not like that. It's like a wind chime, I like that. All right. Does that make sense? So when I see 15x plus 42x, that by itself, those are like terms. So I can put those together.
So it's, like you said, the x carries over, but in the multiplication it's x squared. It's x.
Exactly.
That's what I was trying to make the difference.
Yeah.
Distinction.
So, guys, 2x is x plus x. X squared is x times x. So if you think about it, it's really kind of, on one level, it's just, we had to figure out somewhere to put the stupid 2. Just to tell people what it was. If we put the 2 in front, we're saying we got 2x's adding. If we put the 2 up there, we're telling people we got 2x's multiplying. That's what I mean when I say, when you see both of these, there is no 2 in either one of those. There's no number 2 in either one. And again, that's where students go, we just got to sneak out of here. Office meds, there's obviously 2 there. But this 2x means x plus x. There's no 2 there. There are 2 x's I'm keeping track of. This x squared means x times x. There are 2 x's I'm keeping track of. Does that make sense? So I got 15x plus 42x is a string of 57 x's over 35. That's 70. Right? If somebody put 70 there, what'd they do? They added the bottoms. It makes no sense. I got this many 35ths plus this many 35ths is this many 35ths. Right? The bottom stays the same.
Now, would it say, like, if it was that was on the test, it would say simplify?
Yeah, I would say simplify, carry out the operations,
LCD?
I would probably just say simplify, yeah.
So I have a question on 39, section 4.4 on page 256.
All right, so if you haven't tried this out yet, try this one out. Evaluate.
Oh, wait, I think I just realized.
42.
39.
Minus.
Number 39, section 4.4. Oh, all right. Page 256. The biggest mistake people make here is related to the fact that they're both negative and there's a minus sign in there. Both of those have to be maintained. So remember, what do you do when you plug stuff in place of variables? You put it in parentheses. So I have x minus y. What's y?
Negative 3.
Cool. So the biggest mistake I see on that problem is somebody puts negative 1/5 minus 3/5 because their brain says, oh, there's already a minus there. When really it should say, oh, there's got to be two freaking negatives. One from the problem and one from the number itself. So what happens very first thing? Yeah, so negative 1/5 plus 3/5. And the beautiful thing about that problem now is they already have common denominator. I like it.
Negative 4.
No.
Oh, well, what about the negative?
3 minus 1 is 2. Yeah. Remember, when they're opposite signs, you subtract. 3 minus 1 is 2. You put the bigger sign on, positive. Cool. So you can see, if you still have problems with that, possibly, that never is going to go away. If you still have problems with PEMDAS, that's always going to be there. So those are things that you desperately, if you still have trouble with them, you have got to come see me, get those ironed out. Because they're just never going to go away. Yeah.
So on number 33 on the same page, the denominator's the same. I've got that part. But then it almost seems as though the top is going to be a negative.
Yeah, nothing wrong with that.
And that just seems abnormal to me. Is it okay? I mean, if I work it out, it's going to be a negative.
So if there were, I could represent.
People dumb in the class.
So what's
I
that?
heard somebody say somebody is dumb because they asked that question. I don't appreciate that myself. Don't deny it. I heard it.
Well, if I said it, I would admit it, but I didn't say it.
Okay,
All
I
right.
heard it. So don't.
All right. So be careful. Now, number one, if I don't catch people talking, period, just let me know. So if it's hard for you to hear what I'm saying or somebody else is saying, just let me know. And you got to be careful about taking things out of context, but also obviously don't say anything derogatory about anybody. But let's just keep the talking out for right now. So this problem, what was it going to do? Oh, if I lost 1/3 of something. So let's say last year I had 90. Say I had $90 yesterday, and I lost. Let me get a little bit ahead of where we currently are. Let me see if you guys get this. If I had $90 yesterday, and I lost 1/3 of it. Right? Betting or something. How would I do that problem? Take 1/3 of 90, and that would be 30, and then I can subtract it off. But one way I could represent this, so that would be 90 minus 30, I would have $60 left. If I lost 1/3 of 90, that means I lost $30, I'd have 60 left. So what's it got to do with your question? Well, if I said I lost 1/3 of my money, I can represent that as negative 1/3. I mean, that's one reason that we have negative fractions. Right? So every reason that we have negative numbers of any kind is really the same reason we have negative fractions. Cool. So negative fractions by themselves are nothing to be worried about. It doesn't mean you did something wrong. It could just come out negative. So is it okay then, that problem, besides it comes out negative?
No, yeah, that's fine.
Okay. So any other?
I have one last one.
Yeah.
On the same, section 4.4, 63.
Oh yeah, okay.
And now there's 3 numbers.
4 thirds, 8/21.
Oh, no, 258. 258.
So 3 is 3. Do these two here share any number? So we do it basically like we did before. 21 would be 7 times 3, and 56 is 7 times 8. All right, 7 times 6 is 42. But it's the same exact way we did earlier. Now you just look at each one, you say, what are they missing compared to the other 2 now? Right? So I got a string of like 11 fractions, and you do it the exact same way. What's he missing in terms of all the other 10? So in this case, that first one, what's he missing?
7 and 8.
I like it. So that 3 already has a 3, but he's missing a 7. Okay, you got the 7 covered now, right? And he's also missing an 8. So you wouldn't give him a 7 twice. Once you give him a 7, he's got both of these guys covered in that department, right? So you kind of looking at each one to see what new information do you have for me. So I'm missing a 7. This guy tells me I need a 7. I got it. And I need an 8. Okay, now I got it. You guys with me? And then what's the middle dude missing? 8. And the last dude's missing 3. See, now they're all 8, 7, 3, 8, 7, 3, 8, 7, 3. They're all the same number on the bottom, which is what number? What is that number?
56
168. Cool. So the LCD here would be 168. But you see how that process works? No matter if you have numbers, or you have letters, or you have more than 2 fractions, that process works. So you guys try this one. So find the LCD for these 3. Maybe.
Half of that. Half of that.
Well, let's see now. Wait. So
120.
between the two bigger ones, because 3 is all by himself. He's not going to really contribute too much. Yeah, the biggest thing they have in common is 6. 12 is even bigger than that, right? But if you thought 6, this is where you might have gone wrong. But you can see that what's left over, it's got a factor of 2 in it. So what's the biggest number that those both share? 12. So 12 times 2, 12 times 5. I like it. So what's really key for this to work is that you break them down according to the biggest thing they have in common. Do you see how that factor of 2 made your LCD twice as big as what it really should be? Because it was still kind of there. So now you can really see what's going on. He's missing, now here's the weird part. If you break this down a little bit further, 12 is 3 times 4 times 5. 12 is 3 times 4 times 2. With me? If I break 12 down, because he's already got a 3, so he doesn't need another 3. What does he need? 4, a 2, and a 5. I like it. So he needs times 4, times 2, times 5. Because if you said he was missing a 12, no, he's not missing a 12 because he's already got 3. He's already got part of that 12. He doesn't need the whole 12. What's this guy missing that the rest of him has? He's got a 3, right? Yeah, he's missing. There we go. He's missing. Where am I at? Here. He's missing a 5. Does he need anything else? So now he's got a 5, 3, and a 4 like that guy does. He's already got a 3 there. What's the last guy missing then? 2. So now everybody's got 3, 4, 5, 2. 3, 4, 5, 2. 3, 4, 5, 2. They all have the same bottom.
1 and 20.
What's that?
You did on purpose because that's 2, 3, 4, 5.
I wish I could claim I did that, but I didn't. I won't even try to pretend. So, sorry, do it again?
120. The LCD.
Yeah, 12 times 10, 120, 11. So LCD is 120. Okay. So if you have a different way you do LCDs, and it works for you, then you can keep doing that way. That's perfect. But this way works not just for numbers, but it works for later. It works when you start having variable stuff in there. That's why I like to show it now, because it works really good now, and it's going to continue working forever.
So what if
Do you have to do it like that?
No, you don't. That's what I just said. What did I just say? If you have a way to do LCD that makes sense and it works, continue doing it that way. This is a suggestion. If you need a way to do it, this is a suggestion.
Right, teacher. You have another right?
What's that?
You have another way? You asked if you have another way.
Yeah. I mean, to tell you honestly, what you really should do is to go further with this and break it all the way down to the prime factorization.
that's what I was doing.
I love it. And then that'll take you through. Because sometimes it's difficult to tell who's got what. So if you just break each one down, 24 is 8 times 3. That's 2 times 2 times 2 times 3. 3 is 3. And 60 is 20 times 3, so that's 10 times 2 times 3, so that's 2 times 2 times 5 times 3. All right. Is that cool?
Okay, yeah. Then what do you do?
And now you just do exactly like we've been doing. Now you just say, he's got 3 2s and a 3. He says you gotta have a 3. I got it. He says you gotta have 2 2s, a 3, so far so good, and a 5. Oh shit, okay. Let me give myself a 5. You with me so far? The middle dude, he's only got a 3, so he needs a 2, a 2, a 2, and a 5. Is that cool? And the last dude, he's got a 2, 2, 5, and a 3, so he's missing. Oh yeah, sorry. Another 2. Now see, I got an 8 here. Isn't that 2 times 2 times 2? I just did that because I didn't give myself much room. You guys get that? It's the same idea, except you just take it further to prime factorization.
Could you also write that 2 as 2 to the third power?
Beautiful. 2 to the 3rd power. I only do this method if I do have like 3 fractions and it gets hard to tell who's got what. But if I have 2 fractions, I would never do that method, to tell you honestly. I only have to break it down by the biggest number times something for each one. The biggest number they share in common times something. But you can always take it to prime factorization everywhere if you want to. That will work.
But this way here that you just showed us is going to take us further. Like it's going to help us further.
No. This is the same thing as that, really. It just actually takes that further. It takes it all the way down to prime. So you don't make a mistake with leaving a factor of 2 in here, right? Because you can see everything all the way down to its parts. You can see you've broken it all the way up. So you can tell exactly what he's got, so you can tell exactly what everybody else is missing. Cool. Semi-cool. Okay. Any other questions on homework? What I really want to do right now is give you a few to try from section 4.5. Try these. And the instructions would say, simplify. Call me over if you need some help. So what did you multiply? This is 5 times 3. So he doesn't need it. This was 5. He needed a 1. So you better multiply the top. Good. What did he already have? He already had 5. So you didn't have to multiply that. The 1 never.
Is this rank
Kicks ass. I love it. It's the exact same idea. So it doesn't matter if it's variables or numbers, the same exact idea applies.
So trash.
What did you have to do to this? What did you have to do to this? Multiply by what? No. You better multiply the top by 3 also.
Like just, just like put it out like.
Good. 3 times 3, and then the bottom times 3.
Did you do anything?
Does he need anything done to it? No. If you multiply him by 3, you'll make it 15. It'll be the same.
So then this becomes 3.
Exactly. Because you're multiplying top and bottom by 3. So put a 3 on the bottom. So see, what are you multiplying by actually? 1. So you're not changing the number, you're just changing how it looks. So now it's not 1/15, it's 3/15. And then subtract it.
So off top, I think.
Oh yeah. Or 2x and 7, right? So what's 2x plus 7? 2x plus 7. So just put the whole thing over 15. Who's missing something the other one has? It's missing a lesson. Yep. Multiplying by 2 is on the bottom. No, he's already got that. Who's missing something? So missing multiply top and bottom by 2. Good. Equals. Oh, yes, 115 is not equal to 160. Here. So it was 3 times 5. He was missing a 4. The only way to legally multiply is to multiply times 5, both sides. Just like an equation, you can do it to both sides. I love it. Yes. Perfect. Exactly. It's not too bad, right? I mean, the only way to make it ugly is if you make the numbers ugly. But the idea is simple. That's exactly right. So a lot like the one you just looked at earlier, two up there. He's missing that, and he's missing that.
Oh, and then next, we're talking about this. So 15 times 4 is
6. You can't multiply 1 by something, you might multiply both by something.
I never liked
Yeah, because the weird thing here is the number they have in common is actually does this 20 have a 5 in it? So if you break it all the way down, you'll see it has a 3, a 5, and a 4, and this has a 5. So then you can see exactly what he's missing compared to him. Yeah, if you can't see that 15 is 1/60, then when you write 3 times 20, 20 has a 5 in it. So you can break that down to 3 times 5 is 4, and this is 3 times 5, so he's missing the 4. So who's missing something the other guy has? Good. So give that to the guy who's missing it. Top and bottom, right? Excellent.
times x is not x times x squared. So what is he actually missing?
Okay, we don't want to change
He's
it.
missing
We don't want to change
All right, guys.
Is that the number we want to?
What happens on the first one here? Yeah, it already has an LCD. So 5 over 5, I like it. Equals 1. And very quickly, just in case you need this, visually this would be, if I had 2 fists, that's what that would represent, right? 2 fists. And I added 3 fists, then of course I get a whole 1 full, right? That's really what that means visually. Here, please, dear God, nobody tell me this is 6/10. I didn't see that anywhere, thankfully. We should be past that. That should not even be possible for us to do that.
I got that.
Oh,
No way.
you are now past that. I gotta know you're like me. You're my smart ass. So I gotta watch out. So what can I do here? Now this was not that bad. You don't necessarily have to break anything down if you don't want to, because can you see which one goes into the other one? Yeah, so I know that 5 can become 15, so that's my LCD. Now if you do break this down, 5 times 3, you can see he's missing 3. Now the biggest mistake I see also, and I'm not singling anybody out because several people did this, 1/5 does not equal 1/15. That should be obvious. I can't divide by 5 and get the same thing as I do when I divide by 15. The only way to make it legal, the only way to legally change the bottom is to also change the top. Because then the whole thing stays the same. It's sort of like when you multiply one side of an equation, you better multiply the other side also at the same time, right? Right. Yeah. Okay. So here, if I multiply the bottom side, I better multiply the top side. So overall, I just multiplied by 1. Right? 3 over 3. I multiplied by 1. So mathematically, I'm not changing the number. I'm just changing the way it looks. So this becomes 7/15 minus 3/15, 4/15. Cool. 3 divided by 15 is the same thing as 1 divided by 5, if you did in your calculator. So mathematically, multiplying top and bottom by the same thing does not change the number. It just changes the way it looks. What about here? So I saw a lot of people doing, trying to break them down. Now, here's the, if you don't see that 15 itself is actually in 60, you might make a mistake and say 60 is 20 times 3, and you think that this guy's missing a 5 and this guy's missing a 20. But 20 has 5 in it, right? So he's already got a 5. He's got 5 times 4 times 3. Because 60 is 15 times 4, right? So what is he actually missing that he's got?
4.
The 4. So if you multiply by 4, you can leave this guy alone. You do not have to always change both of them. He's already got everything. He doesn't need anything. He's going to stay the same. 9/60 minus plus 4/60.
13 or 6 over 6.
13, yeah. 13/60. Thank you. Is that cool? Yeah. Now, if you made a mistake, let me just show you. So if you did 9/60 plus 1/15, and you thought it was supposed to be, let me see. You thought this guy needed a 5, and this guy needed a 20. Go with me for a second. Don't even write this down. But if you do this, you'll get 45 over 300 plus 20 over 300. So they are the same denominator. So you can add them together now. You get 65 over 300, but now you have to reduce that. So if you use your LCD, it's not that you're never going to have to reduce, because we had to reduce right here, right? It's just that you're always going to end up with the smallest possible numbers to work with at the end if you use the LCD. This isn't too bad, though. How does this reduce?
5.
Yeah, you can divide by 5. I always remember 60 divided by 5 is 12, so 65 is one more 5, that's 13.
13.
60th, which is the same thing we got there, thank God.
I
Right?
already did it like the way on top. I tried to do like, I guess.
Oh, here?
Yeah, I tried to
Yeah,
do-
sure.
I got it wrong.
Oh shit. That's me now. Okay, that's not as weird as it gets. Let's see. Okay, let's do this one more time. So 60. How did you break 60 down?
I did 6 times 10.
6 times 10. Keep going.
And then, 3 and 3, then 2, 5.
Oh, I see right there. 2 times 3.
Oh, okay.
Yeah.
Okay, I got you.
And then this would be the 3 times 5. So see how there's 3 times 5?
Yeah.
So what's he missing? 2 times 2, that's the 4 you're missing. That would end up being the same way.
Okay,
Okay, good. Alright, sweet. Good. So maybe this is a good way to go in general for us. That's fine. Nothing wrong with that. You can break it all the way down to prime numbers and then just give everybody which prime numbers they're missing relative to the other ones. That always works. It's crazy. If you break things up right. So what about that last one, the funkiest looking one up there? So you got 5 over x minus 3 over 2x. The really beautiful thing about having variables, right, maybe the only beautiful thing about them, is they are eternally factored already. I don't have to do prime factorization. They are factored. Because what's x times y is x times y. I can't go any further. So this is 2 times x. You already know what he's missing. He's missing a 2. Now he's not missing an x. Right? He's already got it, and if you multiply by him by an x, you would get x squared. That would not be good, right? But he is missing that factor of 2. So if you multiply that, you get 10. 2x minus 3 over 2x. 7 over 2x. Done. So variables are numbers. I don't know yet. They have to operate the exact same way as numbers would. Okay. So one last example of this. And this is based on something somebody just asked me about. You guys have all these here? Okay. What do you do if you have something like this here? Oh, let's do this. Sorry. So I've actually combined 2 questions somebody asked me into one. But this is, again, you do not let yourself, don't let yourself always think that it's harder just because there's a variable in it. I'm trying to get you to understand. Variables in these, at least when they're by themselves, not like x minus 3, that's where things get weird, but it actually makes it easier, because like I just said, they're already factored, right? So what's he missing? That number, what's he missing to make it 10? 2. And what's he missing? X. Do you see what I mean? If you look at it as what is each one missing relative to the other one, putting variables in there actually makes it easier because that piece of it is factored already. If one has an x and the other one doesn't, you give the other one an x. And then you worry about the numbers the same way you always do. Right? So the variables are kind of like their own thing to worry about, and they're easy. Because if somebody's got an x and somebody doesn't, you just give it to them. And the numbers, you just treat them like we always do. So 5 becomes 10, and now I've already got a 10, he needs an x. What do I have now?
4.
10x.
All right, so that was part 1. That was one problem somebody asked. Now, the other problem somebody asked me about was exactly like this. Now, the bottoms are the same. I am allowed to put them together now all over 10x, but what the hell is going to be on the top?
4 minus 3x.
11. 4 minus 3x. Because are they like terms on the top? No. So what is 4 minus 3x? 4 minus 3x. So that's what I put on the top.
That's the answer.
That's it. And why can I not, divide by 2? Look, 4 and 10. Doesn't that become 2 fifths? Why can't I not do that?
Not like
No.
there's a division.
is subtraction and division. Those won't cancel. You with me? There's a subtraction. I can't break into a subtraction problem and take part of it away. I can't. So I can never do that. It's so tempting to do that. Right? Especially at something like 2x plus 1 over 2. You're like, come on, man. Let me get rid of that stupid thing. But you can't because it's not fair in a way. How did the 1 escape being divided by 2? It can't. It's being divided by 2 also. Are you guys with me on that? You can only cancel things out when the operations are opposite, and I have addition and division. Those are not opposite. Okay, maybe. All right. So, let's see. Ooh, oh, that's right. I want to make something, let's see. I think what we're going to do is, we're not doing 4-6. That we're not doing. It's on your homework sheet that we're not doing 4-6. We only have 4-7 and 4-8 left to do. We're going to do that next time. Got here a little early. And also next time, the very first thing we're going to do is look at some problems off of page 271 and 272. That's a little review of all the sections before it. So on Thursday, I'll have the quiz graded. We'll finish up chapter 4. There's only 2 sections left. So then the next, I'll have the practice test. Because when's the test?
The 17th.
Good, a week from this Thursday, right? So on Thursday, I'll have the practice test. Next Tuesday, it'll be review day, just like we did before. I'll have the answer key. And then we'll take the test on Thursday, that following Thursday. All right, that's all I got.
Sorry about that.
Oh, it's all right.
Thought I overheard something. I really